Mioara, you are at the CNRS. You've created an algorithm, in fact, that is now being widely adopted to accurately predict the risk of collisions. Okay, Leo Lefebvre at Aldoria, you are a French new space company, and you're using data to actually help protect the satellites that are up there at risk from this debris, and therefore protecting human activities in space. And Imogen, plastic detective, from the world of the oceans, you're a National Geographic explorer and Sky Ocean Rescue scholar. And you're going to be actually helping us see this comparison between these two worlds as such, space and our oceans, and how we're moving between them. Let's get started, though, by actually getting a handle on this space debris issue. Space debris being artificial objects greater than 10 centimeters, is that correct? 10 centimeters. Leo, tell us about the size of the problem and how this has changed a little bit over time.
Yeah, so just a few figures first. So satellites in orbit have been multiplied by 5, up to 10,000. And the known objects, which are catalogued by space surveillance companies such as Aldoria, has doubled between 2017 and 2023.
Okay.
So we are talking about objects taller than 10 centimeters. Mm-hmm. But on the other hand, we have a European Space Agency estimating that space debris less than 10 centimeters and greater than 1 millimeter are more than 100 million in orbit.
100 million greater than 1 millimeter?
Yeah.
Okay, wow.
And they are concerned because they are traveling fast. They travel around 7 kilometers per second. So it's as fast as 10 times a bullet. So when a satellite hits this kind of debris, it creates damage which can end the mission.
Okay. So we've effectively seen a large increase in the amount of debris, a large increase in the number of satellites up there, so sort of exponential increase in the risk as such. But also you mentioned the speed at which these things are traveling.
Yeah, and the collision, which was very unlikely a few years back ago, becomes a real problem. And now when we talk with satellite operators, they proceed to collision avoidance maneuvers on a daily basis.
Okay, well, we have Mioara, who's our collision expert. We're going to talk about that in just a second. But that's the perspectives from space. Let's come down and go to Imogen. Can you give us some comparative data for sort of debris or plastic debris and how that's changed over time?
So I'm quite the odd one out in this panel, in that I'm a marine scientist and I specialize in plastic pollution. And I traditionally look at how it's getting into the oceans, the distribution, and also the impact that it can cause. And I wish it was more profound that I got into literally this space, but it was during COVID, and I was watching one of my favorite films, which is WALL-E, which is a great prediction for the future unless we clean up our act. And there's a significant part in the film where all of the humans are having to escape planet Earth because they've made such a mess. And they have to crash through a sea of satellites. And I was thinking, this seems very familiar. Are we doing it up in space as well, in Earth's orbit? I started to go a little bit crazy. If we compare plastic pollution in the ocean with space debris, there are comparisons. So we make over 400 million tons of plastic every year. 14 million tons of that is expected to go into the ocean. And a huge proportion of that is single-use plastic. But plastic was only made about 100 years ago, with the first synthetic plastic being something called Bakelite. And now it's really exploded, that you just have to look around the room and you can see how plastic has revolutionized our life. With the clothes that you're wearing, the seats that you're sat in, the phones that you're holding, even like your lanyards. But then with space debris, how does that compare? So the first satellite that went into space was Sputnik 1 in 1950. And space is a lot more expensive and harder to reach than the ocean, so it's been slower. But there's 10,000 satellites now in space. But we have a rise in mega constellations, such as SpaceX. And SpaceX is planning on inputting 42,000 satellites into space over the next few years. Because of the Kessler syndrome, where satellites in a crowded orbit can collide, this creates hundreds of thousands of fragments, the more fragments that are there, the more likely they are to collide again, creating hundreds of thousands, maybe even trillions of bits. But we've learned so much of the oceans that then we can carry over to space, such as our lack of governments, international cooperation, not looking after a global commons, lack of financing for solutions, both upstream and downstream.
Imogen, I'm going to actually ask about, and we're going to talk about this in just a bit, but I think you've very well managed to set the scene as to why and how the comparisons there are between the ocean plastics and the space debris issue that Leo sort of gave us the context for. I want to come to the subject, though, of the collision risk, which is what we're focused on. Mioara, this is where your work is indeed focused on. You've developed an algorithm, then, to accurately predict the collision risk. So we've got all this debris floating around all of our satellites, the collision risk here. What is the process for doing that? Can you tell us a little bit about it?
Yes.
Oh, does your mic work? Leo, would you like to kindly swap just whilst I'll take that?
Is it working now? Yes, so good morning, everybody. Thank you all for being here. So I'm kind of labeled like the collision avoidance expert. So I'm just a young expert, let's put it that way, I'm still young. I was working like in the last 10 years already on an algorithm which could actually output a number between 0 and 1. And this number is very important to be reliable because a satellite in orbit, based on exactly whether this number is lower or higher than a threshold, so let's say 1 in 10,000 or 1 in 1,000, depending on this threshold, we will make a maneuver to avoid the debris, or we will not make the maneuver. And of course, this risk has to be kind of assessed based on each satellite operator, each agency. So it was really an important question whether we can reliably assess this number, where we can compute it in a reliable fashion. Mm-hmm. So to get more specific into the science, we currently can have access to the trajectories and the coordinates of space debris and, of course, satellites that are larger than 10 centimeters. That's all we can actually track using radars or telescopes from ground. All the other debris are in themselves a threat, but we cannot monitor them very well. We don't have the accuracy or the precision to see that well in the sky. And based on this kind of more than 30,000 objects that are more than 10 centimeters, they are all catalogued. And their position and velocities are known, but they are not known precisely. In principle, they are only statistically known. So our algorithm takes this statistical information and tries to spit out this number and say, okay, based on this statistical information on the position and velocity, we can say that the probability of collision is less than 0.01%. And then CNES, the French Space Agency, or other agencies can decide whether we make a collision maneuver or not. This is kind of the issue that is in itself currently very difficult to say whether we can reliably assess, or what are the measurements that could actually give us sufficiently good information where we should make maneuvers, collision avoidance maneuvers, or not. Mm-hmm.
And this is where, Leo, you come in. Is your mic working, Leo?
Yeah, I think so.
Fantastic. Okay, I'm going to come to you in just a second, though. So if I've understood correctly, first of all, it's about actually identifying and tracking and collecting all of this data about the debris floating around. And then your algorithm comes in terms of cataloging it and then calculating this probability of the risk, the 0 to 1. Leo, I think this is the way you use this data.
Yeah,
right?
what Mioara said is the core of Aldoria's business. We develop telescopes and we observe basically space from Earth. And this issue of the limit of 10 centimeters is at the core of our R&D project. So we are currently working on telescopes, which by the end of the year will be able to detect objects from 2 centimeters, which will be a huge move forward to have a much bigger view of what's going on up there.
Okay, fantastic. Thank you for adding that in and including how you're working using this data. But why is protecting space important for each of your sectors of work? I'm going to come to you, Imogen, our marine scientist. Why is protecting space important for your work?
I'm still learning how we can use satellites effectively to track plastics. It's quite a new area of research. There's only so much that you can do as one person in the field trying to understand where's all of this plastic going. But satellites, they're basically these huge CCTV cameras in the sky. So I'm currently working on a project with the University of Auckland, and we're looking at sewage discharge in the UK. In the UK, we get a lot of rain, and that means that our sewage systems are overfilling. And that also means that raw sewage is going around the coast, and it's a huge issue. But conveniently, the monitors that the water companies use are also broken, or they're not used. So we have no idea the impact, the distribution, or how much sewage is going into our coastal waters. But by using satellites and these eyes in the sky, we can have a look at where's it going, how often is it happening, and holding water companies accountable to make change.
So it's very much about not being blinded as such. These satellites are giving you that information. Thank you. Mioara, how about for you and your work in research? Why is protecting space important for you?
So I would like to start with a more general perspective. So from the field of research in general and from the CNRS research, protecting a clear space, or also, like we say, a dark and silent space, is very important for many research works in which I'm far from being expert. But the CNRS institution has put up a position paper, stating how important it is for various fields that go from astronomy, from radio astronomy, from stellar physics, from astrophysics, to be able to continue doing research using the space as it is today, and with some more regulations if possible. In the sense that if, for instance, as Imogen mentioned, if SpaceX raises up 42,000 satellites, there was a study in 2022 made from a team using the Vera Rubin telescope that are doing a lot of astronomy measurements, and they work in the visible light spectrum. So if these satellites are up, and they will reflect so much light that in more than 30% of the images they are currently gathering, there will be a trail of light from the satellites. Okay. So most of the images will be compromised. So we are talking now in the visible light spectrum, but we could go in the infrared spectrum, we could go in the radio frequency spectrum, and many issues are present, and CNRS has issued quite an interesting proposal for more regulations that could be made up, and especially that could be proposed, especially in the new space law that the EU is supposed to launch very soon, like maybe this month or so. So we are hoping that this will bring more regulations in order to be able to carry on research that is still important in various fields that are broader than mine. Okay, and I think we're going to touch on the regulation subject in just a short while. So Imogen needs the satellites up there to be able to collect the data for marine science. For space research, it's not just about having the satellites there, but you mentioned clean, dark, silent space as well. So making sure that sort of the data integrity, I guess, and the continuity of that. Thank you for that, Mioara. Leo, why is protecting space important for your sector of work, for our business, communications, military, Earth observation?
Yeah, exactly. As mentioned before in the keynote, our day-to-day life is based on space activities. The whole economy relies on space activities, so telecommunications, positioning, Earth observation, and we see that space access is more and more affordable, so more and more companies are launching more and more satellites. And we see, especially in low orbit, a congestion of the orbits. And we shouldn't take access to space for granted, because once we start the Kessler effect, which has been described previously, there is a possibility, a scenario where those orbits would become completely unavailable. So that's why it's something we should protect, and we should have a responsibility for it.
Thank you. I think this is one of the things I've learned through researching this panel. We think about space as being something that comes out at night when we see the stars. It's there all the time. How many of you are on your phones right now? Yeah, you're using space, okay? It's there all the time, and so protecting it to protect our livelihoods here on Earth is also critical, not just for all the services we're already relying on, but because space is creating new businesses and new business sectors. Aldoria.
Yeah, exactly. The new space is a whole sector, and you can see even another subsector, which is SSA, Space Situational Awareness, which is the sector of the companies trying to map all the debris and to have the full picture I was mentioning before. So all those actors are working for specific services on Earth, but it's become an industry as a whole as well.
Now I want to come back to sort of some of the comparisons, Imogen, that you were making between the oceans and space and the debris, plastics. Well, many of the things we've been talking about here this morning have been about solving the space debris problem and keeping and protecting a clean space. So what are the benefits of that work being done in the realm of space as such for us here on Earth and for your work?
It's all about connecting the environments together. And we were just talking before this panel that many years ago, people said, the ocean is so big, it's not going to matter if we put rubbish and trash in it. We're never going to see the impact. And now you could go to almost any beach and find plastic pollution washing up. And it was Elon Musk that said, don't worry, like, space is so big, we can put as many satellites up there as we want. But now we're starting to see the impact of that as well. I've been told in science often you have to stick in your swim lane. Like, I'm a plastic pollution scientist, stick in your swim lane. Climate scientists over there, space scientists over here. And what we need to do is swim in between the swim lanes and start having this discussion, asking questions, and connecting these environments together, because we'll make faster progress.
Fantastic. Okay, so swim outside of your lanes, people. There's a lot to be learned. Leo, how about for yourself?
You need to think that objects in orbit eventually come back and re-enter the atmosphere, so they burn up for the small part of them. But the biggest one and the most dense ones might not burn up completely and fall on the Earth, which is a risk for human activity. So in Aldoria, we work on this re-entry tracking, so we are able to see if for example, a rocket body or a satellite which is out of service and slowing down is about re-entry, and what is the probability of it to create damage, so that we can have some airspace clearance, maritime space clearance, and protect activities around the place where we have these kind of issues.
Okay. So, Mioara, you mentioned just earlier about sort of the low orbit impacts, and I know that this horrific idea of having a sort of a chain collision here is an issue. But then, Leo, you're saying that that could effectively then also bring more debris down here to space, and that's something you're working on. Okay, so Mioara, for yourself, what is it that we're learning from the space research and the work that you're doing that can benefit us here on Earth?
Yeah, so since I started working on this subject, so I have to say that my initial field were more fundamental or applied math or computer science, and since I've started working on this problem, I have gained a lot of insight, also theoretical, and I think this is important to maybe for the audience to notice that although we are talking about very practical problems today, the collisions are an issue, and chain catastrophic collision is going to be an even bigger issue. But if you look behind the scene, the actual theoretical tools that we use are really kind of scary mathematics. So if I had told you maybe 10 years ago that I worked on solutions of differential equations with polynomial coefficients, you would say, you maybe would have said, this is pointless, this is useless, who will ever use this? But actually, yeah, this is the core tool that we have used in this algorithm that made it reliable and efficient to be put on board. So I think, for me, this is kind of a way of showing that fundamental research or more theoretical subjects can have a big impact even on this very practical and economical-oriented world that we are living in today.
Okay, thank you so much for that. It's fantastic that we've got a researcher here, someone who's actually working commercial activity in space and a marine scientist. I'm going to ask you a very quick, sort of like one-word question. The space race used to mean getting to the moon as fast as possible, okay? Elon Musk changed the target a little bit. He's going to Mars. I want to ask each of you, what does the space race mean for you? What are you shooting for? Imogen.
Education.
Ooh. Good one. Okay, so education and maybe swimming outside of those lanes, as you said, crossing education across and learning across the fields. Leo?
I would say the full picture, so being able to track a millimeter debris in the sky.
Okay, so tracking everything, being sure that we can eliminate the risk and protect our eyes in the sky up there. And yourself, Mioara?
Oh, so for me, growing up in a post-communist Eastern Europe country, I was watching Star Trek. Like, space is the final frontier, believe me. But I think maybe in my lifetime, I will not be able to see the USS Enterprise, right? But maybe I will be able to see, and I think we are all going to be able to see the computer on Enterprise. I think in the next maybe decade or 20 years, we will have the computing capabilities of actually making big progress regarding algorithms and regarding really having an intelligence we can discuss with. So I think for me personally, this is the major impact that we will see in the next 50 years, let's say.
That's a wonderful thing to be racing towards and a wonderful note for us to end on. Thank you so much, Mioara. Thank you to Mioara, Leo, and Imogen. Also to Laurence and Elizabeth for earlier to helping us understand the importance of space, how we are dependent on space in our everyday activities and our lives here on Earth, and how space is critical for helping us mitigate climate change. Also, big thank you to our two dancers from Minuit 12 who joined us earlier. Please do make sure that you follow them on Instagram. And make sure that you catch Laurence, Elizabeth, or any of our panelists here if you want to start working and collaborate with them. Thank you so much for being with us here today and for helping us understand how protecting space is critical for protecting our Earth. Thank you all. Thank you so much.